initiated panels.
Normal.
Normal. Final checklist completed. 50, 40.
Modern airplanes are very complex machines. That's the reason why pilots need intense training and are continually retrained. At the center of these constant training and retraining programs are flight simulation exercises, so as to increase safety and efficiency of air travel. A nuclear power plant is technologically even more complex than an airplane. Each and every operator needs to have a thorough knowledge of all its detailed workings. "24 hours a day, specially trained crews supervise the proper functioning of the plant from the control room. Measuring, regulating, and recording equipment provide data on this huge installation. The power plant is built in order to produce energy. Electricity, a vital form of energy both for the industry and for our daily comfort. It is the task of an electric utility to produce electricity in a continuous and safe manner. Safe operation automatically leads to an efficient utilization of the nuclear power station. Inefficiency would, of course, increase the bottom line of our energy bill. In many cases, operational problems are the result of human error. In order to guarantee its safety, one needs people with a perfect knowledge of the operation of a nuclear power plant. In the course of their professional career, operators continually undergo further training, and every 2 years, their license is up for renewal.
Nou, nog 1 gram. Gewoon zou worden is 10 tot de 23ste, maal 10 tot de 16e is 10 tot de 39ste, maal 10 tot de min 27.
Prospective operators are subjected to rigorous selection tests. Immediately upon hiring, they start a 2 to 3 year basic training.
Wat dan gebeurt als u uraal T35 een neutron invangt, dan wordt het uraal P36. Ben je eens?
During theory lessons about the working of a reactor, the trainees test their acquired knowledge on a basic simulator. This device simulates the nuclear reactor and the primary system. Its working is influenced by various parameters. To approximate reality even better, future operators practice on a test reactor of the Dutch Energy Research Center at Petten. However thorough this basic training may be, it does not suffice to make someone a fully qualified operator. In the complex control room of a nuclear reactor, he needs to know exactly how and from where every component of the installation is operated. For this reason, being faced with a real installation, both in normal working conditions and in emergency situations, is of the utmost importance. A simulator is the ideal tool for such practical training, the way it is for pilots. Thanks to the simulator, pilots can safely and without using one drop of fuel go through each phase of a real flight. They practice situations that cannot be safely achieved with a real airplane. A simulator is like a gigantic computer game. The computer processes in real time the plane's behavior in response to the pilot's actions. Can something similar be achieved for the operation of a nuclear power plant? Carefully study the picture below. No, it's not the control panel of Doel 4, but the simulators at SCALDIS. You'll not find a nuclear plant behind these panels, but 4 powerful computers, painstakingly imitating the working of Doel 4. This simulator is a safe way to reproduce any situation, even the most exceptional ones. This simulator makes it possible to provide future operators with the most diverse types of training situations. For instance, normal working conditions, working with incidents, or in case of an accident. These training modules are a perfect completion of the basic training and constitute the core of the operator's 2 to 3 year total initial training. After this training, every operator will receive a yearly refresher course of 1 month, including at least 1 week's working on the simulator at SCALDIS's training center. The SCALDIS Training Center is located in an ultramodern building in the proximity of the thermal power station at Kallo. The Doel 4 simulator consists of 3 main components. The control room is an exact replica of the one at Doel 4. The computer center, with its 4 computers, is the heart of the simulator. These computers simulate in real time the behavior of the nuclear power station. Finally, we have the instructor's panel, where the conditions of the simulation are determined. The instructor has switched off the reactor. The future operators commence the startup procedure. Let's have a look at how it's done. The control rods restrain the nuclear fission. They are lifted very slowly. Nuclear fission is thus initiated, and the reactor releases its heat energy, which is ultimately transferred into steam. On the simulator, the operators start lifting the control rods. It looks exactly as if a real reactor was starting up. We measure the neutron flux and determine the point where the reactor will get critical. At that moment, the controlled chain reaction will be initiated. The operators continue the exercise in order to produce electric power. First, the turbine is started and run up to 1500 RPM. Next, the voltage of the generator is made equal to the voltage of the grid. Connecting the power station to the grid is done by synchronization. To the operators, it looks as if they really started up Doel 4. They gradually increase the electrical power level. The exercise is finished. Each exercise is discussed afterwards. The next exercise is prepared together with the instructor. The operators will be confronted with an incident situation. One of the control rods drops into the reactor core. Thanks to the simulator, the operators can train themselves to handle this situation in a safe manner.
Erik?
Ja, Erik, we hebben een probleem met ons staf in een groep. We zijn al tussen al op hand gegaan. Wilde jij instrumentatie verwittigen voor eventueel die staf terug op te trekken? Dank u wel.
Ja, Leo, Erik hier. De bediening van de controlestralen die is terug volledig in orde.
The objective of these training courses is to get the operators acquainted with the whole installation of the power plant, to show them the work and safety procedures, to get them to understand and control their actions, and to tune them in to those of their colleagues. The simulator is an indispensable tool to understand the working of a nuclear power plant and to master its operation. A simulator will help future as well as experienced operators to field test their way of thinking. Real conditions and situations are imitated behind these control panels by powerful computers. In order to simulate the Doel 4 nuclear power station perfectly, the control room was completely copied, and the computers reproduced the working of the actual power plant. Hence the term full-scope simulator. At Doel, you'll find other nuclear power plants in operation besides Doel 4. With adapted programs and parameters, the same simulator will simulate Doel 3. For Doel 1 and 2, a second special simulator was built. So the SCALDIS Training Center has two simulators. SCALDIS started training on a simulator in January 1989. It took 6 years to design, build, and fit this center with one of the most complete simulators of its kind in the world. Including design studies and computer software, its completion ran close to 2 billion Belgian francs. About 60% of the total investment was awarded to Belgian companies. Belgian contractors erected the buildings. Fabricom and Vanquier built and supplied parts for the control room panels. Gould Belgium supplied the computers. All studies and the overall coordination were provided by Tractebel Engineering in close cooperation with IBES. Thomson, the worldwide renowned French specialist in simulator construction, built the simulator itself. For months on end, the behavior of the nuclear power plant was translated into mathematical models by Tractebel, Thomson, and IBES. Having been programmed with these mathematical models, the computers provide an accurate simulation of the power plant. Each modification made to the Doel power plant is implemented in the computer program of the simulator. In this way, the simulator remains a perfect copy of the real power station. Before SCALDIS was operational, the operators used to be trained at Électricité de France at Bugey, Caen, and Palluel. However, their simulators imitate the French power stations. The difference with Doel was felt as an obstacle to proper training. SCALDIS's full-scope simulators, impeccable duplicates of the Doel power plant, provided the solution. SCALDIS offers training and retraining of operators for these nuclear power stations. These simulators make it also possible to test certain operating procedures. It was clearly with these arguments in mind that Belgian legislators required such simulators. SCALDIS, a cornerstone of the safe and efficient operation of IBES's nuclear power plants at Doel.